Okay, AP Calculus AV, Unit 9, Day 1, office hours. These are the answers you can check real quick. Pause the video if you need to. First four are just drawing pictures, no numbers. Pause the video if you need to. Next one's gotta show some work. I'd draw some sketches, different estimation techniques. Okay. Here's the ones on the back. Estimate and exact. Estimations and exact answers. And the last ones, I would have drawn some pictures to help you figure out which ones are which will help you avoid memorizing as much as possible, which is probably the best thing. Okay. So we did problem 5 in class yesterday, or in the lesson. So here's the sketches. It says 2 subintervals. So we would, if they're equal subdivisions, equal width. Left in is the left side. And this one's kind of interesting. It looks like they're both like the same height. And you can kind of shade it in. So that's that one. 3 subintervals. Try and like cut into 3 equal slices. We're doing right in this time. So that's the right side. Shade it in, show where you're calculating. Next one would be 4, cut in half, cut the halves in half. It's my quick way of getting nice fourths. Midpoint is right here, so you're actually in the midpoint, the height at the halfway point. Okay. All right, and this one would be 3 equal slices. Trapezoids, you're connecting the endpoints, little secant lines, and it creates these trapezoids that are kind of vertically oriented. So that was it for those. And then the next ones, we did 5 together. We're using all the values in this table to help you. So if we're going to do 3 subintervals, I would draw a quick picture and say, okay, we're going to do from 1 to 13, 3. So that's the distance of 12 divided by 3 is 4. So it's going to be 5 and 9 to give you bases of 4, right? And then you look up the values. Number 1 is 7. Number 5 is 4. When x equals 9, we're at 7. And 13, we're at 1. I'm doing right end, so it's the right side, so we're not going to use that one. And that's the area we're trying to estimate. So 1 to 13, f of x dx is approximately 4 times 4, 4 times 7, 4 times 1. So that's 16 plus 28 plus 4 is going to be 48. So that's our integral of 1 to 13, f of x dx. And using this symbol right here is the most appropriate symbol. This is a rough answer. In fact, these are estimating the same function over here. Different techniques, different numbers of slices. More slices is better. So midpoint, this is going to look just like the last one, except for midpoint, we need to find the spot in between them. So the distance is 4, so it's always going to be 2. So we're looking at 3, 7, and 11. Right? Okay. The bases are still 4. And there's still just 3 rectangles. But we got to look at these values. 3 is at 2, 7 is at 6, and 11 is at 4. So this picture is just kind of just a rough way of organizing your information. There's 3 rectangles. So 1 to 13, f of x dx is approximately base 4 times 2. So the 3, 7, and 11 don't show up in your calculations. We had to look up the values though. And then 4 times 6, and then 4 times 4. So that's going to be 8 plus 24 plus 16. So that's going to be 48. So the integral 1 to 13 of f of x dx is approximately 48. All right, that's how we do it. Okay, next one is midpoint, but 2 slices. So this kind of looks like the one right above it. But we got to go halfway to 4, halfway to 10, and look up these values. So at 4, the value is 1. At 10, the value is 8. So we have 2 rectangles. So 1 to 13, f of x dx is approximately base 6 times 1 height plus base 6 times 8 height. So that's 6 plus 48 is 54. There you go. All right, next one. 6, 1, 2, 3, 4. I'm just gonna 6 slices. So we're starting 1, 13. The gap is 12. Divided by 6 is 2. So this is gonna be 3, 5, 7, 9, 11, 13. Perfect. Each of these is 2. So 1 is at 7. 3 is at 2. 5 is at 4. 7 is at 6. 9 is at 7. 11 is at 4. 13 is at 1. We're doing right in, so we're using the right sides. So we're not going to use that first left side. All right, so 1 to 13, f of x dx is approximately base 2 times height 2, base 2, height 4, base 2, height 6, base 2, height 7, base 2, height 4, base 2, height 1, which is 4, 8, 12, 14, 8, 2. And so that's going to be 12, 24, 28, 38, 46, 48. All right, next one's trapezoids. So I think just like the one above it, actually the very first problem would be helpful. Quickly, it's the same values, but we can do trapezoids. These are the heights of the trapezoid. So remember, the area of a trapezoid is base times height. It's a rectangle, base times height, but it's the average of the bases. So the average of the base is 6 plus 7 over 2 times the height 6 plus the average of the base is 6 plus 1 over 2 times the height 6. So that's going to give you 3 times 13 is 39. 3 times 7 is 21. So we're going to get 60 is the approximation of the integral of f of x dx from 1 to 13. Okay, next one's trapezoid with 4. 1 to 13. I don't think we've done a 4 yet. So it's 12 divided by 4 is 3, so it's going to be 4, 7, 10, 13. Right? And so at 1, we're at 7, at 4, at 1, at 7, we're at 6, at 10, we're at 8, 13, we're at 1. So we're going to connect all these to make little trapezoids. And this picture is really just to help me set it up. So average of the bases, 1 plus 7 over 2. So you guys show this work in the A-B test to convince them you're doing trapezoids. 1 plus 6 over 2 times 3. 6 plus 8 over 2 times 3. 8 plus 1 over 2 times 3. So let's see. That's going to be 8 over 2 is 4 times 3 is 12. And that's going to be 7. It's going to be 21 halves. That's going to be 14 over 2 is 7. That's going to be 21. And that's going to be 9. It's going to be 27 halves. So let's see if we get 33 plus 48 halves, which is 24. So we get 57. 1 to 13, f of x dx, 57. So there you go. Some good practice with some of the details of those. On back, we can do some more, but create our own tables, and also find the exact answers. So during our lesson, I did number 12. So that one's all done. So 13. Make a table, 3 subintervals, starting at 2, going to 8. The distance is 6, divided by 3 is 2, so it's going to be 4, 2, 4, 6, 8. So we plug 2 in here, so 8 minus 2 is 6, 64 minus 4 is 60, 216 minus 6 is 210. Do it on paper if you need to. 8, oh my gosh, what's an 8 cubed? 8 times 64, 32, carry the 3 to 48. 512 minus 8 would be 504. Okay, so I'm gonna make a little table here. I'm gonna do right end, 2, 4, 6, 8. So we got 6, 60, 210, 504. Doing right ends, so we're doing right side. Don't need that one. So 2 to 8 x cubed minus x dx is approximately, bases are each 2, times the height 60, base 2, height 210, base 2, height 504. So that's going to be 120 plus 420 plus 1008. All right, so 2 to 8 x cubed minus x dx is approximately 1548. Okay, now exact method. We're going to actually integrate it. This is something we started doing last unit. So x to the 4th over 4 minus x squared over 2, antiderivatives, and then we're going to plug limits in, 8 first, then 2. So you plug 8 in, that's going to be 8 times 8 times 8 times 8 over 4 plus, oh, and then you also got to plug 8 into both of them. Yeah. And then minus, then you got to plug in 2. 2, that's 16 over 4, minus 4 over 2. Okay, this is going to be a big number. 8 times 8 is 64. 8 times 64 is 512. Times another 2 is 1024. Minus 32. Minus 4 minus 2. So now it's going to be 2. So I'm subtracting 34, so it's going to be 990. 990. That's the exact answer. Crazy. All right. Next one, 2 steps, Make a quick table. 2 to 10. Gap is 8. So it's going to be 4. It's going to be 2, 6, 10. And plug in x squared plus 4x. Plug 2 in. We get 4 plus 8 is 12. Plug 6 in 36. Plus 24 is 60. Plug 10 in as 100. Plus 40 is 140. Looks like I did the wrong thing in my solutions. Interesting. Whatever. Okay, we can make a quick picture. 2, 6, 10, and 12, 60, and 40. These are midpoints. Ooh, no, I did the right thing. So midpoints, shouldn't even bother calculating. Midpoints are going to be halfway between these. So I need 4, and I need 8. So we plug 4 in. 16 plus 16 is 32. Plug 8 in, you get 64. Plus 32 is 96. That's what we're going to use. 32, add 4, and 96. Those are the triangles. All right, bases are still 4. There's only 2 rectangles still. Don't think of it as 4 rectangles. So the integral of x squared plus 4x dx 2 to 10 is approximately base times height, and base times height, and that's going to be 128, and this is going to be, well, I think 400 minus 16, 384, 12, carry the 1, 512. So 2 to 10, x squared plus 4x dx is approximately 512. Okay, exact. We're going to integrate x squared plus 4x from 2 to 10. Integers x cubed over 3 plus 4x squared over 2 from 2 to 10. So you got to plug 10 in first. So if you plug 10, that's going to be 1,000 over 3 minus 200. When we plug 2 in, it's going to be 8 thirds plus 8. And then we got to, oh, that should be a plus. And we got to distribute that subtraction. So let's see, does it work out nice? 992 thirds plus 192. Does 3 get 992? Add the digits. 9 plus 9 is 8. 18 plus 2 is 20. Then 3 is not going to go in, unfortunately. So we have a couple options here. We can give the least common denominator. 3 times 192. 6, 27. Carry the 2 to 3 is 5. 576 plus 992. 8, 16. Carry the 1 to 14 is 15. So we could say exact answer is 1568 thirds. You could say that's also 522 and 2 thirds, but whatever. Okay, last one of these, trapezoids, 6 of them. So we're gonna make a table. We got 1 to 13, gaps 12, divided by 6 is 2, so 2, 3, 5, 7, 9, 11, 13. I'm gonna plug these into x squared minus x. Plug 1 in, you get 0. Plug 3 in, you get 6. 25 minus 5 is 20. 49 minus 7 is 42. 81 minus 9 is 72. 121 minus 11 is 110. 13, 169 minus 13 is 156. Draw a picture. 1, 3, 5, 7, 9, 11, 13. 0, 6, 20, 42, 72, 110, 156. So when we connect them, this is just really a rough picture. This is just to really kind of put all the right numbers in the right spots. Now, this first one, you'd be like, that's a triangle, that's not a trapezoid. You can still use trapezoid formula for a triangle. Triangle is pretty much like a trapezoid where one of the bases is 0. It works. Okay. Okay, average of the bases, 0 plus 6 times the height. 6 plus 20 over 2 times the height. 20 plus 42 over 2 times the height. For 2 plus 72, 72 plus 110. 110 plus 156. Okay, what do we get? Luckily, check this out. Oh, yeah, all the 2's cancel. That's nice. So we're going to get 6, 26, 62, 114, 182, 266. We just got to add all those up. Okay, so 12, 14, 18, 20, 26. Carry the 2. 8, 16, 17, 23, 25. Carry the 2. 6, 656. So our estimate, 1 to 13, x squared minus x, with 6 equal subdivisions using trapezoids, is about 656. Now for the exact answer. It's going to be x cubed over 3 minus x squared over 2. We've got to plug limits in. So that's going to be, oh my gosh, 13 cubed. Oh my goodness. What's 13 times 169? 27, carry the 2 to 18 is 20, carry the 2 to 3 is 5, 0, 9, 6, 1, 7, 9, 11, 21, 2197 over 3 minus 169 over 2 minus, you plug 1 in, that one's easy, 1/3 minus 1/2. So, does 3 go in 2197? I don't think so. Nope. So, is our best bet like, 2197 thirds minus 1/3 is 2196 thirds. And negative 169 halves plus 1/2 is going to be negative 168 halves. And 3 goes into this. Well, 3 goes into 2100. 700 times 732 minus 84. Borrow. 648. 648 is the exact answer. Wow, that one was a bit of work. Okay, our estimate is pretty close, for only 6 slices. Okay, last ones. Which methods gives an overestimate? Left, right, midpoint, or trap? Okay, we're looking for overestimate specifically. Increasing concave up. I draw a picture. Quick picture. You have curve, it's increasing concave up. Let's just do 1 slice. Okay, if you do 1 slice, we're looking for overestimate. Left in is going to be overestimate. Left in for sure. Okay, right in won't. Sorry, no. Left in, right in will be right in. Now, the other one, our trapezoids are easy. Look, if you draw a trapezoid, that's definitely an overestimate. So if it's concave up, trapezoids will always be an overestimate. Just draw the line. It'll show it's above it, right? Midpoint is midpoint's the hardest one. So if you're to do this, if it's concave up, the graph is getting, oh, actually it should be right here. Concave up, the graph is getting steeper as you go, and you're getting more underestimate than overestimate. So that one's an under. Next one, decreasing and concave up. Decreasing and concave up. So left end is going to be overestimate for sure, right? Trapezoid is going to be an overestimate for sure. Midpoint is going to have, right here, more over than under. And by the way, it's either left or right, and it's either trap or midpoint. I guess, if you remember that, that might narrow it down quicker. Increasing concave down. Well, right end is going to be the overestimate, right? Trapezoid is going to be under, which kind of leads me to believe that midpoint will be the over. But if you draw it, midpoint, you're going to get more over here, and the graph, because it's concave down, the graph is getting less steep, and so the under part is less than the over part, so it's over. Okay, decreasing and concave down. So decreasing concave down. Left end is going to be the over estimate for left and right. Trapezoid is going to be underestimate, which means midpoint should be the overestimate, if you remember that. But if you draw the picture, it should kind of make sense. You're getting more over than under because it's concave down. So there you go. Those are the, that's it.